The purity of our drinking water is a problem that needs to be solved. Years ago, there were plenty of sources of pristine water for humans to consume. Today, humanity has expanded tremendously, and there are no longer sufficient sources of pure water available. Human activities like agriculture and industry generate huge amounts of contamination. Civilization has contaminated rivers, lakes, and groundwater with pathogens, pharmaceutical and healthcare products, and endocrine disruptor compounds that affect aquatic life and are taken into municipal drinking water plants. Some plants already use advanced treatments to eliminate these contaminants, but soon every plant will need to do this. In arid regions of some parts of the world, facilities are now entering operation to treat wastewater for direct potable reuse, which necessarily incorporate highly advanced treatment trains. Carbon has been used since prehistoric times to purify contaminated water. The U.S. Environmental Protection Agency has identified filtration through activated carbon as the best available technology, or BAT, to remove many of these emerging contaminants. This material has up to 1,500 square meters of surface area in each gram of carbon, thanks to its extraordinary porosity. But there are some problems with this use of carbon. As contaminants in the water adhere to this surface area in the pores of the carbon, its absorption capacity becomes exhausted, and the contaminants begin leaking through the filter. The carbon bed is a dark, warm, humid place loaded with organic material. Ideal conditions for bacterial growth, which can escape with the effluent water. The carbon is often exhausted in about 6 months, meaning it must be regenerated or changed out twice a year. To regenerate the carbon, it must be unloaded from the filter and sent to a special furnace, which is almost as expensive as replacing it. Disposing of the spent carbon is also expensive and problematic due to the contained contaminants. There are some partial solutions. Several researchers have shown that activated carbon can be chemically regenerated, in other words, reactivated. For example, by a heated alkaline wash, by an acid wash, or by washing with a solvent. However, chemical reactivation is rarely used because of the cost of the chemicals and the treatment of the wash solution. Soaking the carbon in chemicals uses less water but is time-consuming and inefficient. A better solution is to backwash the carbon with ozonated water, which regenerates and disinfects the carbon while oxidizing the desorbed contaminants. This process was patented by Ozone Polaris in 2016. Backwashing with ozone, though highly effective for many contaminants, can require as much as 90 minutes. That's a lot of backwash water, and some contaminants need the added effect of chemical washing. We have a new solution for that: washing with back and forth water flow. Our first attempt at solving this limitation involved recirculating the backwash water. However, in less than a minute, the nozzles in the filter underdrain clogged with carbon fines. Installing a filter in the recirculation line yielded the same unsatisfactory result. The solution we found, and the subject of a new pending patent, is to wash with back and forth flow between two filters, or between a single filter and an auxiliary tank. As can be seen in this sped-up clip of two transparent 8-inch pilot filters, the back and forth flow can continue for a long time without clogging the nozzles. This process permits extended washing cycles with minimum consumption of water and chemicals, and just a small volume of wash water to be treated. It allows us to keep the effluent water quality within strict limits and prolongs the life of the carbon from months to years. For the pressure filters commonly used by industry, it is perfectly feasible to wash the filter media without unloading it from the filter, daily if necessary to keep bacterial growth under control. For the open filters commonly used by municipalities, washing can be done in batches with a 2-tank washer installed near the filters. This would be done with a frequency like that normally used for changing the carbon. The back and forth washing process generates a minimum amount of dirty water, which facilitates its treatment and disposal. Between wash cycles, ozone can be used to oxidize the desorbed contaminants. By washing with ozone once a week and with chemicals once a year, for example, the useful life of the carbon may be as much as 10 times its normal life. The contaminants we humans discharge to the environment affect the life of the planet and endanger humanity itself. By purifying water with activated carbon, incorporating this new process to make it more economical, we have a sustainable solution to the growing needs of civilization and a boon to life on the planet.